Hi, everybody. Uh, I know when you talk about radicals of radicals, it probably makes your head hurt. But here's a very interesting radical. Square root of 1 plus square root of 1 plus square root of 1 plus square root of 1 forever. That sort of reminds us of the continuous fraction we looked at earlier that ended up equaling this funny number phi. It's about 1.618. That was the fraction 1 plus 1 over the 1 plus 1 over the 1 plus 1 forever. We call that a continuous fraction. We could maybe call this a continuous radical. It'd be interesting to find out what this continuous radical was equal to. Well, notice that if I look at just the square root of 1 plus 1, that's going to be the square root of 2, right? And then if I look at the square root of 1 plus the square root of 1 plus 1, notice that this part right here is exactly this part I just did right here. So notice that this is going to equal the square root of 1 plus the square root of 2. Now we can do that on our calculator. If I find the square root of 2, that is about 1.414. Okay, and then if I look at the square root of 1 plus the square root of 2, all I'd have to do on my calculator is take the square root of 1 plus that answer. Okay, so this is going to give me the square root of 1 plus the square root of 2. If I hit enter, that's about 1.55377. And I can continue in this same way. Notice that if I did it, added one more 1 in there, I'd have the square root of 1 plus the square root of 1 plus the square root of 1 plus 1. But of course, all this right here is this very problem we just did up here. I know that's going to equal, the square root of 1 plus the square root of 2. It's this number right here, right? So I know that all this is the 1.55377 number. So all I have to do on my calculator is take the square root of 1 plus my previous answer. You see that? In other words, all I really have to do is just hit the enter button again, and it's gonna do this step I just did, but my answer is now updated, and I get 1.598. Okay, so that ends up being 1.5980, blah, blah, blah. Okay, and I can just keep doing that. And notice that, again, if I do another step, this here is just this previous answer. So all of this is the 1.5980 that's in my calculator. So if I do the square root of 1 plus answer again, I'm going to get this answer, which is 1.6118. Blah, blah, blah. And all I have to do is just keep hitting my enter button, and I will be getting closer and closer and closer to what that repeated radical is, that continuous radical. And you'll notice that it looks like it's getting close to that very same number, that 1.618. In fact, it is. It's getting closer and closer to that number. So if I come down here and put, like dot, 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 all right, this ends up equaling 1.618033 989. Be sort of interesting to know what that number is, but it's interesting that it ended up being the same thing as the continuous fraction. The motto of the ancient Pythagoreans was all is number. All is number. And they also believed that in the beginning was the one, as in the number one. So it's interesting how all these ones sort of add up and give rise to this interesting number phi, whether I'm doing a continuous fraction or a continuous radical, and then this number phi shows up in nature in all these different places. All right. Well, here's something else interesting as we move forward with our understanding of algebra. If I was to let x equal this number, this repeated radical, square root of 1 plus square root of 1 plus square root of 1. Notice that this set of radicals in here is exactly x, right? Because the square root of 1 plus the square root of 1 plus square root of 1 forever is x. So notice that that gives me that x is going to equal the square root of 1 plus x. And if I could solve that equation, that would tell me what x was. All right. Well, notice that what I could do here, and we will be solving radical equations before too long, is I would square both sides to undo the square root, and I would get this equation that x squared equals 1 plus x, or x plus 1. Which is interesting because it's the polynomial equation where you've got 1x squared equaling to 1x plus 1. All right. Now, notice that if I was to bring this over and solve this quadratic equation, try and solve by factoring, it doesn't factor, right? In fact, we see that the solutions that are going to be irrational, it's going to be something real close to 1.618. All right. Notice that we could do something similar when we'd had this continuous fraction. Notice if I let x equals 1 plus 1 over the 1 plus the 1 over, this part right here, that whole thing there equals x. So this is the same equation as x equals 1 plus 1 over x. And we know how to solve equations like that, right? It's a rational equation. I'd go ahead and I'd multiply both sides by that common denominator. And if I do that, I would get x squared equals, sure enough, x plus 1. It's the same equation we got up here, right? And I would, again, bring those over. X squared minus x minus 1 equals 0. It's the same equation. And we can solve that graphically. If I solve it, the x squared, this would be y equals x squared, and this would be y equals x plus 1. You can see this line here. And if I find the point of intersection, you see that it is x equals 1.618. That's that golden ratio phi. Or if I were to bring everything over on this side and graph y equals x squared minus x minus 1, I can find that 0, and that 0 right there is 1.618. All right. So, but still, it'd be interesting to know how could I solve that equation algebraically to get the exact value of that. And that's what we're going to be looking at going ahead. We're trying to solve every quadratic equation, not just the ones that can be factored. All right. So I hope you find that interesting. We'll see you next time.